Good morning class. Today we will see half wave control rectifier with the inductive load. In last lecture we have seen operation of half wave control rectifier with a resistive load. Here we have used one more element at output side, that is a inductor. We are knowing we are using inductor as a filtering element. So let's see the operation. Before that we must know the property of an inductor. When a current flows through the inductor gets energized. The property of inductor is inductor opposes any change in current. Don't get confused between inductor and a resistor. Lots of times students get confused between inductor and resistor. A resistor opposes to current, but inductor opposes to any change in current. The changes may be in terms of magnitude or in terms of direction. So inductor tries to maintain current through it constant. Okay, so let's start with the operation. Now we will see the operation during positive half cycle and during negative half cycle. Here it's the circuit diagram, and here the output voltage waveform for the operation of half wave control rectifier with the inductive load. Here we have used a step down transformer. The input given to the step down transformer is a single phase 230 volt AC. Now during positive half cycle, that is from 0 to pi, the terminal A becomes positive and B becomes negative. So our SCR gets forward biased, and as soon as we apply the gate pulse at an angle alpha, here this is the firing angle alpha, and at this point we have applied a gate pulse to the SCR. So SCR starts triggering. Remember one thing, forward biasing of a SCR and conduction of a SCR, these are two different things. When diode gets forward biased, immediately it starts conducting. But this is not a thing with SCR. SCR gets forward biased when its anode becomes positive with respect to cathode. But when we apply a gate pulse, at that point only it will start conducting. Okay. So at this point SCR starts conducting and we will get this kind of output voltage. Now the SCR is supposed to stop its conduction at an angle pi, but as we see in waveform, it is not happened over here. Let's see why this. Okay, so because the terminal A becomes positive and B becomes negative, SCR gets forward biased, and we have applied a gate pulse at an angle alpha. So current starts flowing through the circuit like A, SCR, R, L and B. So this is the path. Once again we will see A, SCR, R, L and B. So now look at the inductor. The upper terminal of inductor becomes positive and lower terminal becomes negative. Okay. So at an angle pi, what happens? Terminal A becomes negative and B becomes positive as the negative half cycle starts. So the current flowing through the SCR, suddenly it becomes 0 because of A becomes negative and B becomes positive now. But according to property of inductor, the inductor will not allow this, because the current flowing through the inductor now suddenly falls to 0. So now inductor changes its polarity. Now this terminal becomes negative. Okay, this terminal becomes negative and this becomes positive. Now this positive terminals is going to apply to anode of SCR and negative to the cathode of SCR. So momentarily the SCR becomes in a forward biasing mode, and now the inductor starts de-energizing, and now the current flows from L plus, B, A, SCR, R and L minus. Now this is the new polarity across inductor. Once again I will repeat, the inductor will get de-energized and the current will start flowing through the circuit now as L plus, B, A, SCR, R and L minus. So this is the path of the current now. Okay, so this is the path of the current. We can see here, this is the path of the current. Our SCR is supposed to stop its conduction at this angle, but it starts continue its conduction say from angle pi to pi plus alpha. Let's assume that the inductor continues to conduct up to and firing angle alpha. Okay. What happens at this point? At this point, the secondary voltage becomes greater than the voltage across de-energized inductor, so that our SCR gets reverse biased and now it stops its conduction. So here SCR stops its conduction. As we know, during the negative half cycle, terminal A becomes negative and B becomes positive, so SCR gets off now. It gets reverse bias, so will not goes into the conduction. So we will not get output voltage during this period. Now at 2 pi, the next positive half cycle starts. So after an angle alpha, so say this is your 2 pi plus alpha. At this instant, we have again applied a gate pulse to the SCR. So at 2 pi, A becomes positive again, B becomes negative, and at 2 pi plus alpha, we have applied a gate pulse. So SCR again starts conducting, and the same kind of operation repeats itself.